gentlemen, as we are about to begin, I introduce myself first. My name is Nurul Nadia and it is my pleasure to be your MC this morning. Assalamualaikum and good morning everyone. Welcome to the Agro-Food Productive Webinar on Epidemiology of Bird Flu, Highly Pathogenic Avian Influenza, HPAI, and its threat to Malaysia. We have here Professor Dr. Abdul Rahman Omar as our moderator.
Thank you.
Short introduction about Prof. Dr. Abdul Rahman Omar. He obtained his Doctor of Veterinary Medicine from University Pertanian Malaysia in 1991 and PhD in Immunology from Cornell University, the USA in 1997. He was the Director of Institute Bioscience, IBS, at UPM from 2011 to 2019. Currently, he is the Dean of Faculty of Veterinary Medicine, UPM, and Principal Investigator at Laboratory of Vaccine and Biomolecules, IBS. He has more than 20 years teaching and research experience in avian disease and health. He published actively in various journals related to poultry health and disease, which can be accessed via NCBI site using search name Omar AR. Now, without further ado, I will pass this session to Yang Bersaha Professor Doctor. Thank you.
Thank you very much, Cik Nadia. Bismillahirrahmanirrahim. Assalamualaikum and a very good morning. Welcome to the webinar on the epidemiology of bird flu, organized by the Federation of Livestock Farmers Association of Malaysia and the Agro-Food Productivity Nexus, and in support by the Malaysian Productivity Corporation. It is indeed a very important meeting this morning. We will discuss about avian influenza, about bird flu, one of the leading poultry diseases of threat to the global, where at the moment now, both the highly pathogenic avian influenza as well as the low pathogenic avian influenza can significantly impact our poultry industry. Malaysia have experienced a few episodes of HPAI, especially H5N1, was reported in 2004. And then the recent one was reported in Sabah in 2018. Since 2018, we are free from HPAI. We have very good experience. Malaysia has been very successful in controlling this so-called highly pathogenic avian influenza. Okay. In the case of low pathogenic avian influenza, there are several strains of concern. Of course, we have the H7N9 and also the H9N2. Currently, there is no reported incidents or cases of H7N9. However, since 2017, Malaysia, we have experienced a few cases or repeated cases of H9N2, a low pathogenic H9N2 in several commercial poultry farms. Based on some of the studies that have been carried out recently, the virus is still detected in some of the poultry farms in Malaysia. So what we can see now, the epidemiology of the so-called avian influenza is changing, where now we are seeing the highly pathogenic avian influenza are more readily detected in migratory birds. Now we are seeing also hotspots areas. We used to know hotspots area in Asia, but now we have also hotspots area in Europe, where we have seen every now and then outbreaks of the so-called highly pathogenic avian influenza. Okay? So when it comes to avian influenza, of course, control and prevention strategy are of paramount importance because it can really significantly impact the poultry industry. Strategies adopted to control HPAI and LPAI varies from country to country. So this morning's presentation seminar will be very important, where we're going to discuss the epidemiology of avian influenza and its threat and it poses to the Malaysian poultry industry. And we want to also to explore what are some of the strategies and protocols that we can actually take to control both highly pathogenic avian influenza and also low pathogenic avian influenza. Further ado, let me introduce the first speaker for today's webinar, Dr. Marcelo Tafuri Paniago. Currently, Dr. Marcelo is the Director of Veterinary Service, Ceva Asia and Animal Health Asia. Dr. Marcelo received his veterinary graduates from Brazil and then continued his master's degree in preventive veterinary medicine and business administration. He spent a short time working as a lecturer in a university, and then he moved to industry working with Agro-Food, I believe this is avian in Brazil, where he spent almost 10 years there. And then in 2004, he joined Ceva Animal Health in Asia. Then he moved to France. And since January 2017, currently he leads the veterinary service group of Ceva Animal Health Asia. He has been working extensively in poultry sectors for over 34 years. Without further ado, Dr. Marcelo, the floor is yours.
So my topic today is to bring some information in terms of epidemiology and highly pathogenic avian influenza, but also low pathogenic avian influenza, that major source of concern for Malaysian producers today. And as Prof. Rahman mentioned in the beginning, we are going to touch some points in terms of prevention. And at the end of this seminar, I'll be here to answer any eventual question that you might have. But let me start by highly pathogenic avian influenza. The first thing, if you see this graphic here, that was all the reported outbreaks from 2008 to 2018, we can see that this disease has been detected pretty much everywhere. So with the exception of South America and Australia, all the other regions have been affected, either by H5N1, H7 and 9, or any other of those viruses, but this is everywhere. But what is happening nowadays, again, is something that we have to be a little bit worried about. Look at this very, very recent publication, was published last week, showing the cases of avian influenza from October 1st to November 26th. And you can see that there are, again, new cases in Europe. So as Prof. Rahman mentioned in his introduction, that there are some hotspots, and Europe has to be considered one of them. Every now and then, this region is facing problems, and we can see this. If you give a little bit of a zoom in this region, this is again a very recent publication. You can see in the fine print here, there are more than 400 detections. More than 400 detections in Europe, in countries like Germany, Belgium, Croatia, Denmark, France, Ireland, Italy, pretty much everywhere. And not only in commercial birds, not only in layers, not only in breeders, but also in wild birds, and even in captive birds that they call zoo type of birds. So, but you see that they are facing again, or it seems that it's the beginning of a new wave of avian influenza in Europe, where pretty much what happened in 2015, what happened in the end of 15, the end of 16. So they are extremely concerned in Europe. But this has somehow an explanation. If you see all these waves that have hit Europe in the past 10, 15 years, you can see that all of them could be traced back to migratory birds. And usually these birds, they migrate northwards during the spring, after April. In May, June, they start migrating westwards, and then by October, these birds start to arrive in Europe. And these birds carry avian influenza virus. So any contact with commercial birds or any contact with other type of birds can trigger the contamination, the infection, and the spread of this disease. So this was the way that happened several times, 4 times now. We are facing the 5th wave. And after this introduction, it's very common that this will contaminate, this virus will spread in Europe and even reaching more distant areas like Africa or even Middle East. But Asia is not free of this type of contamination, because the virus can also go eastward. And we are seeing this exactly happening now. Probably you have seen this in the news, that South Korea and Japan have recently confirmed HPAI cases in those countries. So again, now and then South Korea, now and then Japan also face this type of problems. And the question that remains is that, what about Malaysia? Is Malaysia under risk of getting this virus spilling over here? Well, we can never say never, right? This is something that we cannot predict. There is a risk, obviously there is. But one thing that we can say is that Malaysia has been hit by highly pathogenic avian influenza, all of them H5N1. But the Malaysian government, the Malaysian authorities were able to eradicate this disease in a very, very professional way. In 4 different circumstances, in 4 different cases, in 4 different locations, we are able to eradicate this virus. So if the virus hits Malaysia, and I would like to touch the wood here, not to hit, but I feel that the government has the experience, has the knowledge enough to deal with this situation, right? But now we are dealing with something that is we don't have as much experience as highly pathogenic avian influenza. And when I mention we, I mention as the poultry sector and all the stakeholders involved, the producers, the legislators, and everybody that is involved directly or indirectly with this sector. So let me spend a little bit more time dealing with low pathogenic avian influenza that I'm sure is a source of concern today. Well, if I come back to that first graphic that I showed in the beginning of my presentation, all the avian influenza detections from 2008 to 2018, we can spot just few cases of low pathogenic H9N2 avian influenza. And I had to really look into details to be able to spot them here. And it seems, H9 is not really a problem. It's not highly pathogenic. It's much more visible, much more problem caused by this. Well, this is not the truth. And one of the reasons is that the notification of H9N2 to authorities, to OIE, for instance, is not mandatory. So that's one of the reasons why you don't see so many H9N2 in this graphic. But if you try to see where this virus is circulating today, there was a publication last year, July last year, that the authors put in this map all the countries that are dealing or have identified the virus in their frontiers. And you see that in China, it was firstly detected in 1992 and it still remains there. And then all these countries, and going towards Africa, Middle East, Africa, India, Pakistan, Iran, Iraq, Egypt, Libya, Algeria, Morocco, now even going down towards the south of Africa. And of course, as we know, is also going down towards the Southeast Asia. Indonesia is here, Malaysia is here in this graph, although saying that the virus was not identified at the time of the publication. But this is July last year. And I just put here 4 or 5 more countries, Yemen, Ghana, Senegal, Kenya, Sudan, that just declared that was positive since 2019. So probably there are even more countries that have declared and I could not find. So the reason and the truth is that the virus is spreading to everywhere. This virus spreads in a way that we have never seen before, right? But let me proceed with that. What about H9N2 in Malaysia? The first report that I could find in the literature was in this publication that dealt with all the detections of all the virus that were found here in the country between 1980 and 2017. And if you see when they go down in all these virus that have been detected here in Malaysia, most of them low path, so not reportable, but one of them was H92, right? And this was in 1998, and with no major consequences. Probably this virus was only detected in some birds. It didn't spread to the commercial birds, so no consequences. But more recently, as we all know, there was a detection back in 2017 of this virus, low pathogenic avian influenza H9N2 subtype in Malaysia. And this very nice publication from BRI details very well what happened, the type of virus that they found. And in that publication, there were two different types of virus. One of them classified as Korean. This was found in the northern part of the country in Perak and Penang. But the most prevalent in those days, and in 7 out of 11 isolates that were studied in this publication, belong to Y280. And even in the publication, they mentioned that this Y280 was present in various parts of Peninsular Malaysia, like in Penang, Perak, Malacca, Negri, Sintang. Well, but after this, we have to say, well, but low pathogenic as compared to highly pathogenic. Highly pathogenic, we all know the consequence. It kills birds. It has direct consequences in terms of exports. So what are the consequences that could be attributed to low pathogenic avian influenza? Well, at least 3 points we have to understand in terms of low path avian influenza. The first one is the economic impact of this virus or this disease is very difficult to be measured. But it's thought that this disease, the low path H9N2, causes more severe damage, I mean economic damage to producers than highly pathogenic avian influenza. This is something that there is the perception that this virus is even more troublesome to producers as compared to high path. Hard to imagine, but that is the perception. That is what the major author says. And it's very well documented, its association with several other pathogens like infectious bronchitis, like Newcastle disease, or even highly pathogenic avian influenza, and several others. So at the end of the day, this virus, although, I repeat, although is classified as low pathogenic avian influenza, it causes tremendous economic damage in producers. Another point that this virus, we have to pay attention to that, is that this virus is potentially a zoonotic virus. So this has been documented, and one of the lineages that is associated to human infections is exactly the Y280, the lineage that circulates today in Malaysia. And another point that's also related to this potential zoonotic risk of this virus is that it has been described that this virus can contribute to internal genes to other viruses, including the H7 and 9, the virus that Prof. Rahman mentioned in the beginning that caused severe problems to humans in China 4 or 5 years ago. So you see that there are reasons for the authorities, for the producers to be concerned about H9N2. But not only that, there is one more reason that I would like to draw your attention to. When you compare eradication of H9N2 with highly pathogenic avian influenza, in highly pathogenic avian influenza, several countries have been able to eradicate it. And I will start with Malaysia, as I mentioned, was able to eradicate 4 times, but also Philippines, Thailand, South Korea, Japan, USA, France, the Netherlands, Germany, Italy, England, and you can list several countries here, right? But how many have been able to eradicate H9N2 since the virus became endemic? To the best of my knowledge, there is no one single country that has been able to eradicate this virus. So it's very complex, it's very difficult to deal, it causes tremendous economic problems, so we need to deal with that. Well, but then the question that comes is that if eradication is not feasible, what could be done, right? This is a fair question, and I would like to explore this a little bit further. And now we start with a quote that was done very recently in a publication of 6 months ago. This author, Cho, is a Korean guy, and he mentioned, although immunization of inactivated LPAI vaccine cannot completely protect against viral infection and shedding into the environment, vaccination is one of the most promising control measures to date for H9N2 LPAI. So, according to this author, these researchers, vaccine is still the best candidate or the best weapon that we have to fight against this disease. But then, how many countries are vaccinating? Well, there are several countries vaccinating. I mean, officially vaccinating. I don't consider countries that are smuggling vaccines, but countries that are vaccinating. In this publication, in this presentation in 2018, there were 18 countries, and today I could put 3 more here. Bangladesh has adopted this vaccination, and at the end of last year, Indonesia, same thing, and now Malaysia has started the vaccination. And Vietnam is the next in line. Probably in the middle of this year, they will start vaccinating against H9N2. So the industry recognized that, well, as eradication is not feasible, at least in a short period of time, with the weapons that we have today, we have to vaccinate, right? But then the question that comes is that, what can be expected from vaccination? Well, we all expect that the vaccines will protect against the negative impact of the virus, the negative consequences of this disease. Yes, of course, this is the minimum of what the vaccine has to do. But is there anything more? Is there anything that we could learn from other countries? So I decided to compare one publication, very recent publication from Korea, and I decided to compare Korea and Malaysia because there are some similarities between these two countries. First, the area. If I consider here only West Malaysia, where most of the poultry industry is located, its size is almost similar to Korea. The poultry industry is of similar size. In Korea, they have a little bit more layers, but broiler industries is the same. And another point that's very interesting, the two countries have been able to eradicate highly pathogenic avian influenza. Malaysia, as I mentioned, 4 times, and South Korea, they eradicated 6 times. And now they are going to have to eradicate it again. Probably they will go for 7 times. But let me present to you in a very summarized way what we could learn from this publication. The first one is a brief history of H9N2 in South Korea. The first outbreak happened in 1996, and then for 3 to 4 years, till 1999, 2000, the Korean government tried to eradicate the disease, the virus. And they had stamping out measures, they had compensation, but this policy didn't work. It didn't achieve complete eradication of disease. So then in 2007, the government decided to allow vaccination. And they distributed 1 master seed. The master seed that was isolated back in 2001 was used to vaccinate the birds. And since then, since 2007, this country has routinely vaccinated birds. But what have they achieved? The first point is interesting. In this 10 years, 11 years that this study covers, more than 600 million birds have been vaccinated, or a million doses have been used. It started back in 2007, 10 million doses, and they reached up to 80 million doses in 2017. Bottom line, if we take into consideration the numbers of 2017, approximately 50% of the layer chicken farms and 50% of the breeder chicken farms are vaccinated against H9N2, right? But then what they did, they surveyed the titers that these vaccines were inducing. And there are 5 laboratories producing vaccines in the same master seed, as I mentioned to you. And you can see that there are some slight differences if you compare here the laboratory A and laboratory B. There is almost 1 log difference. This end line here, the last line here shows the average of each lab, A, B, C, D, and E. So there are some differences in terms of vaccine, probable vaccine quality. But bottom line, after 10, 11 years of survey, there was a 5.82 log 2 of antibody response to this vaccination. And according to the criteria adopted by local authorities, they wanted to reach more than 6 log 2 in pathogen-free chickens, specific pathogen-free chickens. They are somehow happy with these results. In my experience, we could reach higher antibody response than 6 log 2. But this is a different story. And one point that I would like to draw your attention is very interesting. According to the regulations, 20 to 30 birds have to be placed as sentinel birds with each vaccinated flocks. And 10% of those vaccinated flocks have to be surveyed, have to be taken a blood to evaluate the circulation of virus. In 2007, 18% of the farms still showed that the virus was active, or in other words, there was seroconversion in those sentinel birds. In 2008, this number reduced to 9% of the farms, and from 2009 onwards, there has not been report of positive sentinel birds. So it shows that the virus that was circulating massively in the past now is more under control. So in, what these authors mentioned in the beginning is that there had not been reports of H9N2 outbreaks in broilers or breeder farms in Korea more recently. There has been only 3 outbreaks from live bird market in 2017 and 1 case in 2018. So they consider the situation is much better controlled today as before the beginning of vaccination. But now the last point that I would like to address is a concern of vaccination. Will vaccination against H9N2 increase the virus mutation rate? I think this is a valid concern, and I wanted to bring some information to you. And I could find 3 different publications dealing with the same point. The first one was published in 2018, and what these authors did was very interesting. They had some SPF hens, and they vaccinated these birds with 3 doses of H9N2 vaccine to the point that these birds reach more than 9 log 2 in terms of HI titer. And they had eggs coming from SPF birds without being vaccinated. So they had the first generation of eggs that had been vaccinated, and they injected this strain of H9N2. F98 is a strain of H9N2 that was isolated in Shanghai area back in 1998. And they injected this strain in eggs from vaccinated hens and eggs from non-vaccinated hens. And they harvested the virus from these eggs, and they injected in the second generation of eggs. And then they harvest the eggs here 3 days after the injection, and then they inject in the next generation. And they did it for 80 times, 80 different passages, okay? And then they measure the difference in terms of virus to see whether the antibodies that was induced, that was passed on to those eggs would have an impact on the change of the virus. At the end of the day, of course, they measure several criteria, but I would just like to read the conclusion. The selective pressure of the antibodies does not seem to play a key role in antigenic drift in the egg model. So these authors didn't see that there was much more difference in those virus that was propagated in eggs with antibodies as compared to eggs without antibodies. But this is in eggs, right? What about in birds? So this different group did very similar situation, but now instead of passing in eggs, they passed the virus in birds, the same strain F98, and was injected by nasal drop, eye drop in laryngeal injection, and in the first generation of birds. 3 days later, they took the trachea and the lungs of these birds, they macerate this material, they took the supernatant, and they injected it again in the second generation of the birds. 3 days later, they harvest the trachea, they harvested the lungs, and they inject in the next generation. And the same procedure was done with birds that were not immunized with that same virus produced, the vaccine produced from the F98 vaccine. At the end of the day, they compare the virus and the 20th generation between these two, and they comparing these two viruses with the original virus. And again, they measure several points, but in this trial, they even went further. These workers mentioned that the selection pressure of the vaccine antibodies play a role in regulating and controlling the gene mutation. So there was less change in the virus that was replicated in the birds that had antibodies. There are some criticism in terms of methodology of this I specifically have, but these authors point out in the same direction of the first one in X. But the last one, and the one that I like the most, is one that was conducted in Korea, and they studied the evolutionary dynamics of H9N2 from 1996 to 2012. And you can see that in those days, there were 2 different clades that were circulating before the start of the vaccination. And after doing several studies, and we don't have time to go through them, but they saw that there was an increase in the genetic diversity between 2003 and 2007, before the introduction of the vaccine. The vaccination was introduced in 2007. And then there was a sudden decrease in 2007. So the conclusion of this author says that the implementation of the H9N2 vaccination program in Korea has dramatically reduced the diversity of H9N2. But these authors also advised one point that's important. The periodic update of the vaccine seed strain should be considered to maintain the control of H9N2 AFPI outbreaks. Okay, so unfortunately the time is limited. I have to go to my final considerations. But one point that I will have to say is that yes, there is a risk of introduction of HPAI as Korea is facing today, Japan is facing today. But Malaysia has proven its capacity, its capability, its knowledge to eradicate this virus. So we have to trust in our authorities that if eventually this virus comes, they are very well equipped to deal with that. The second point is that H9N2 virus most likely will be entrenched in the country for the unforeseeable future. As I mentioned, eradication is not easy. But the Malaysian authorities, they readily approved the use of autogenous vaccines, and the poultry industry is really ready to implement these rules. And this is very positive. Contrary to Korea, you remember, the detection was in 1996, and only in 2007, the government took the decision to vaccinate. So you imagine the losses during that period. But one point that for me, the most important point of this presentation, proper vaccination is critical for the success of H9N2 control. But proper vaccination means quality of the vaccine, homology of the vaccine strength, the circulating virus, the proper schedule, proper injection, proper follow-up of vaccination, right? And finally, the use of sentinel birds might be an easy way to assess the circulation of H9N2 virus in vaccinated flocks, as it was done in South Korea, right? Then my final slide is that these are the references that I had to read to prepare these presentations, and I'll be very happy to share with you if you are willing to go to see them, right? Thank you very much for attention, and once again, I really appreciate the opportunity to come here and sharing what we have learned about this disease. Thank you.
Thank you very much, Dr. Marcelo. Let us move on to our second speaker that will be delivered by Dr. Rozanah Asmah Abd Samad. Currently, Dr. Rozanah is the Director of Veterinary Research, Department of the Service Malaysia. She is a very experienced and professional veterinary officer with a very strong interest in improving animal health, welfare, and veterinary service in the country. She has been working with Department of Service for more than 23 years, and with a lot of experience dealing with controlling and eradicating major emerging diseases in Malaysia, especially when the country faced problems with Nipah virus outbreak, and then the HPAI, H5N1, babies, and also on equine encephalitis. Dr. Rozanah did his PhD on avian influenza, HPAI, in Japan. She's also currently the Secretariat for the National Antimicrobial Resistance Committee and is the OIE National Focal Point for Veterinary Products. Okay, with that, Dr. Rozanah, the floor is yours. Thank you very much.
Okay, thank you very much. Assalamualaikum and very good morning. Thank you, Prof. Moderator, for introducing myself. And today I will be talking on the topic given to me, that is the protocols for prevention and control of HPAI. Okay. Okay, these are some of the guidelines for my presentation. I will give some introduction about DVS, the vision and mission, function of DVS, and then briefly about what is HPAI, even though the earlier panelists have already explained in depth what is HPAI, but since my topic is still part of the protocols and prevention, I would like to briefly introduce what is this HPAI, and then history of HPAI outbreak in Malaysia, then protocols for animal disease management that is based on the 5 principles, and then 5 pillars of animal disease management, establishment of disease area, zoning, communication flow, and then lastly, the protocols for prevention and control of HPAI in Malaysia. Okay, as for introduction, because I made to understand that most of the participants may be not familiar what is this DVS, or the full name Department of Veterinary Services. So let me introduce briefly about this department. It is one of the department under Ministry of Agriculture and Food Industry, recently been changed, and then the abbreviation is MAFI. And then for your information, DVS is the only competent authority in managing animal health and veterinary services in Malaysia. So what is the vision of this department? just to become a competent veterinary authority in serving the animal industry. And as for the mission, to provide quality veterinary services as an assurance for public health and sustainable livestock industry to ensure the safety of human well-being. Okay, these are the functions empowered under our Animal Act 1953. And as you can see, the first one is to control, prevent, and eradicate animal and zoonotic diseases. This is the main function of Department of Veterinary Services in the country. Of course, on top of that, you have other activities related to animal health and animal-based product. So actually, the veterinary services of the veterinarian is to ensure the safety of the food from farm to fork. But in Malaysia, we are a bit unique. The jurisdiction of Department of Veterinary Services is from farm to processing plant. Once the product have been packed and goes to the retail, is under the purview of different ministry. Okay, so briefly, what is HPAI, or the name is highly pathogenic avian influenza. This is the schematic diagram of avian influenza virus, and this is under the electron microscope. Maybe it looks similar like COVID, but it's totally different virus. And it's a disease caused by avian influenza virus of subtype H5 or H7. So at the moment, already proven scientifically, the highly pathogenic is only caused by these two subtypes, even though other subtypes can have some potential gene, but this is already proven, these two subtypes, H5 or H7. Okay, these are the map to show the history of HPAI outbreak in Malaysia. Okay, we first experienced the highly pathogenic avian influenza virus H5N1 in the year 2004. And the first outbreak was in Kelantan that occurred in a village chicken. Okay, we suspect this from the introduction of this fighting cock from the neighboring country. And then we managed to eradicate and gain disease freedom. But unfortunately, in 2006, we were infected again, and this is quite a number of states were involved in this 2006. So severe in 2006, there's the state in West Peninsula is having infected with this avian influenza, highly pathogenic avian influenza virus. And then this one also we managed to eradicate and gain disease freedom. And in 2007, there's another outbreak occur in one premise in the state of Selangor. Then also we managed to eradicate and gain freedom. And after 10 years without having any outbreak of HPAI, but unfortunately in 2017, we do get again the outbreak, and it's the same in Kelantan also in 2017. But we also managed to eradicate and gain freedom from this HPAI. So for Peninsular Malaysia, the last case is in 2017 and up to today. Okay. But in Sabah, in East Malaysia, we had first HPAI outbreak in 2018 that occurred in one of the district in Sabah, that is in Tuaran. So then this outbreak also we managed to eradicate and gain freedom. So up to today, Malaysia is free from highly pathogenic avian influenza H5N1. Okay, these are just to show the protocols for animal disease management. So Malaysia did adopt and adapt these 5 principles. That is the prepare, prevent, detect, respond, and recovery. These are the principles provided by the FAO and OIE in managing animal disease. And Malaysia, we do adapt this principle. So once there's an occurrence of animal or zoonotic diseases, so if we consider this as a crisis situation, then we will quickly deploy our rapid response team to do further investigation. Why we need to do this? Because we want to control the disease spreading further and to reduce damage and losses. So this is what Malaysia or DVS have been doing in curbing the animal disease outbreak. Okay, so the 5 pillars of animal disease management, what DVS is been doing for the preparedness stage, we have in place our rules and regulation, the Animal Act, the SOPs, protocols, contingency plan, and also simulation exercise. These things are to prepare all the personnel in the department to be aware, always in an aware mode when we are being struck by certain animal diseases. So we have to have all these preparedness measures in place. Okay, and then the second one is the measures of prevention. So what did DVS do all the while? We have this activity, farm and processing plant inspection. We do have this national disease surveillance and control program at all animal premises and also our processing plant. We do inspect regularly. This is part of our prevention measures, meaning that if we do detect any disease occurrence, we can take prompt action to prevent the disease from spreading further. On top of that, other part of prevention, we do auditing for the farm and also processing plant. Not only locally, we do also visit and audit the country where they want to export their live animal or product into the country. We have to make sure that this animal status is healthy enough before introduced into the country. So we do site visit and also we do this import risk analysis, meaning that we don't simply bringing animal or animal product into the country without doing any assessment on the risk of introduction of the disease. And another part of prevention control, we have this border control. We work with Makis, another department under MAFI, to main the border and all the products that coming into the country. Of course, we do quarantine and movement control when there's certain outbreak in certain identified premises. Of course, we have to take this movement control measures. So after this preparedness, prevent, another pillars is detection. Okay, how do we detect disease occurrence? As I mentioned just now, we do have this surveillance program in place, be it active or passive surveillance. Active is the planned surveillance program where we do conduct yearly. And on top of that, we also receive reports. That is a passive surveillance where then we do deploy our investigation team to the infected area. And then this surveillance comprises not only the farm, processing plant, any premises that have animal activity, we do surveillance. We do have this surveillance national surveillance program yearly. Okay, and then other from this surveillance, other method for detection is traceability. This health cert being issued by the authority before the animal can be moved from certain farm to processing plant or to the abattoir. The authority have to do inspection to make sure that these animals are healthy enough before it can be slaughtered. On top of that, we also introduced this so-called animal health declaration, where the farmer have to declare that their animal are healthy, and most importantly, didn't use any antibiotic or drug within the withdrawal period before it can be marketed, because we don't want to have all these drugs residue. And then after this health cert, animal health declaration being submitted, then only the department, the veterinary services or the authority will provide this movement permit for this farmer to move their animal to the slaughterhouse. And then on top of this, for traceability also, we have this ID premise, animal ID, carcass tagging. If you can see, some of our carcass sell or at the market have this tagging, meaning that it had been inspected by the authority. This is to ensure that all these animal products are safe and healthy for human consumption. Okay, then the other pillars is the response. We have this so-called disease index management, meaning that when we detect certain disease occurrence in the animal premises, we will take the sample and send to the lab for further confirmation, and then all the activities to control the disease from spreading further is being conducted. And then actually this disease index management is a color-coded system. So we give this color to help to facilitate our staff to know the status of these premises. Then after certain activity, when the disease is being resolved, then it will gain a freedom status. So the activity of movement of this animal and animal product from this premise will go back to normal. And then in the situation where we do have outbreak of disease that have economic or zoonotic impact, then we will activate the so-called crisis management center. This center actually is similar to the CPRC in Ministry of Health. And now they're so actively when they have this COVID. So this crisis management center at DVS is a center to collaborate all the information, data coming in, data coming out, going out, and also all the policies, instruction have to come from this crisis management center. And then at the state level also they have this operation center. Okay, and then we start to mobilize our investigation team to do further investigation in order to determine the source and the spread of the disease. And then another response is zoning or compartmentalization. Okay, we have to establish this in order to take proper control measures in different zones. If we don't have this zone or compartment, all the activities will be in chaos. So we have to identify the zone or the compartment. And then of course we have to have a movement control. And then on top of that, the part of the response is culling and stamping out. In animal, we have a leverage to cull or to stamp out the infected animal. Okay, this is to stop the circulation of the pathogen. I think this one also applies in the COVID situation, but because of human, you cannot cull, but you have to cut the circulation by asking the human to stay at home, to have physical distancing, to wash, sanitize your hand. So same goes in the animal disease outbreak, but we can just simply cull. Okay, and then after culling all these things, you have to disinfect and decontaminate the affected or infected areas. Okay, and then after all this response have been finished, of course, recovery period where we need the farmers, their livelihood have to start back. So we have to have the surveillance program also in order to determine that there's no more this disease around, so that the farmer can safely restock back their animal and also start back their farming businesses. And some of the diseases we do compensate, actually just to give some token for the farmer to help to ease their the problem. Okay, the establishment of disease area. So this is the zone that we do establish is under our Animal Act and also being recommended by OIE. So the name of this zone, it depends. This one is the infected zone where we identify the index case and then we plot the radius, how many distance for infected area, and then we will have different activities. Usually on this infected area, all the risk animal population will be culled. And then there's, of course, there's no movement control. We will have quarantine in this area. Then outside this infected area, there's another zone called disease control. This is, we have active surveillance program to make sure that the disease from this infected area or have been spread further, or is there any new foci? That's why we have to have this disease control area. And outside this disease control area is called disease eradication area. Usually at this area, we do have surveillance, but maybe it's a passive surveillance, and this area, the eradication area, is to facilitate the trade. Usually the trade can resume at this eradication area, because if you don't identify the zone or the compartment, the whole country will be suspended from exporting. That's why we need to establish this zone or compartment in order to facilitate trading and export. Okay, determination of disease zone. Actually, how we determine the zone, and it's not simply that we put how many kilometers. We depend on the epidemiology, the pathogenesis, or the mechanism of the disease or the pathogen. So in the infected zone, we will do culling, decontamination, movement control. Not all animal will be culled, only the at-risk animal will be culled in this infected zone. For example, like highly pathogenic avian influenza, we don't cull cattle, we don't cull other animal that is not at risk. We only cull the avian species. And then on top of that, if certain commercial or farm located in this infected zone, but if this farm practice good biosecurity, good closed system, maybe we can spare this farm, even though it's located in this infected zone, from being culled. That is why we encourage farmer to have a good biosecurity and closed system housing. Okay, and then this control zone. What are the activities under this control zone? Of course, as I mentioned just now, we have to have active surveillance in order to know whether the disease has been spread from the index case or not. And then, of course, movement control. Maybe this movement control is not as strict as movement control under this infected zone. We give some leniency, depend on the commodity. And then maybe some cases we can do vaccination under this control zone. Eradication zone actually is a free zone. We do have also surveillance, maybe it just passive surveillance. It's not as active as the surveillance in under control zone. Okay, and then movement control, maybe, what does it mean here? Maybe from the infected zone, we don't allow any movement into this zone. So maybe there's a question raised, how many kilometer radius we will determine from the infected index case. So it's not necessarily 1 kilometer radius from the index case. It depends on the biosecurity of the infected farm. If the farm that were infected is commercial farm, for example, having good biosecurity, maybe only this infected farm will be quarantined and all the risk animal in that farm will be culled. But in Malaysia so far, we experience HPAI in village chicken, because village chicken, we know they read freely or free range. That's why we have to put up this 1 kilometer radius, because it don't have a clear demarcation or boundaries. Okay, depends again, as I mentioned just now, depends on the biosecurity of infected farm, nature of the disease, capacity and capability to control the disease. Okay. Okay, this is how the communication flow, meaning that all the reports, either from the active surveillance, from the farm, from abattoir, will go to this ADIC or Animal Disease Information Center at DVS. And then this center will be, there's somebody in charge, and they will analyze if they found something abnormal occurring in this report or the information. They will alert this alert management team, headed by the Director of Biosecurity and SPS Management and other head from the same division. And then they will analyze and evaluate the information. If this is a crisis situation, then they will activate this so-called Animal Disease Crisis Management Center and then start to deploy the investigations team, so-called Rapid Action Team. And then this team will go to the infected premise or farm and do further investigation and epidemiological investigation. And this rat, once they will deploy and then they do investigation, they take sample, they were given so-called green lane passage, same like when we enter from the airport. This meaning that if the sample come from this rat team was sent to the lab, respective lab, and then at that time, whatever activity testing being conducted had to be stopped and give priority to this sample from the rat, because it is a crisis situation. We need to know urgently what is the disease all about to take necessary action. Okay, these are the protocols for prevention and control of HPAI, because these are the topic given to me, so I have to explain in depth for this situation. Okay, so again, highly pathogenic avian influenza is caused by avian influenza H5 and H7. So basically, we know there are 144 subtypes, because we know H1 to H16 and N1 to N9. So it's a combination of these two protein or gene will form the 144 subtype. It is an avian influenza that causes fatal in human. When we talk about HPAI, not LPAI. HPAI, fatal in human, because it can cause huge economic losses and zoonotic. So for HPAI to occur, it needs domestic chicken and poultry, meaning because the passaging, the mutation will occur in this domestic chicken. From the low path, actually all the virus, the reservoir is in the migratory bird or the wild bird. Then when it infects our domestic chicken, then the passaging, due to this passaging, the mutation will occur, and then from low path, it can change to highly path. And then usually it will associate with disease and death in poultry and also in wild bird, meaning that after the virus changed to HPAI from the poultry, and then it passed back to the wild bird. Okay. Okay, for preparedness, as mentioned earlier, but this is specifically for HPAI, we establish SOPs, protocol, manual, rules and regulation, and you can go to our website, in fact, to see the protocols for control specific diseases, okay? And then the capacity and capability building and education as a part of preparedness. We have to develop our laboratory personnel to be capable of detecting and diagnosing all the emerging disease. Okay, and then of course our personnel also have to be trained properly, and then that's why we need to have this regular simulation exercise, either field or tabletop, because even though we have the knowledge, but if we don't really practice, we tend to forget. That's why we need all this simulation exercise to maintain their skill and capability. And then another part is also called field epidemiology training. And for the awareness and education, like this webinar, to all the stakeholders and general public, we have to increase their awareness and educational program on what are these impact of zoonotic diseases. Prevention. We have this, as mentioned earlier, we have this National Disease Control and Surveillance Program, farm and processing plant inspection, we have this border control, we have to collaborate between DVS, enforcement, and the marquis, the law enforcement, police, army, custom, and immigration, because at the border there's quite a number of law enforcement. It is a multi-sectoral collaboration. And then quarantine at the port of entry. And for this whole test release, for any product of poultry base coming from the risk country, after doing all the risk analysis, auditing, we still have another measures, meaning that once the product or the animal arrive at our quarantine station, we don't simply release yet. We take the sample, test, and then when it confirmed negative, then we will release to the respective farm or the processing plant. This is called whole test release. We don't simply take sample and then release without knowing the result. So of course, import risk analysis and then quality assurance. Now Malaysia is introducing this MyGap certification, meaning that this farm having a good biosecurity, good criteria, and then can give assurance to general public that all the products from this MyGap farm or the inspected processing plant, the food is safe and wholesome for human consumption. And then the vaccination program, as mentioned earlier, for LPAI now, the authority have revised the control measures. We are allowing the usage of vaccine to control LPAI H9 and 2. Okay, we don't simply allowing without doing deliberate research, pro and cons about this vaccine. Okay, and then another prevention measures, as mentioned earlier, farm and animal registration, this is animal health declaration, animal movement permit, and veterinary health permit. This is part of the prevention measures. And for detection, of course, under this National Disease Control Program, surveillance program at the farm, processing plant, we take sample, we do surveillance in order to give the authority early warning or early indication of some disease occurring in the animal premises. And then border control, sharing information on zoonosis. This is the One Health collaboration between DVS, Ministry of Health. At the moment, we share all the zoonotic information during the meeting, or sometimes if urgent, we can just communicate through WhatsApp or emails, okay, to share, to give some alert, early notification. Multidisciplinary collaboration, this is so-called One Health, animal health, public health, environmental health, and bilateral collaboration, especially for the trans-animal, boundary animal diseases. This is very important also now because there are so many emerging diseases that can occur from our neighboring country. That's why we need to update regularly. Okay, response, as mentioned, disease management, crisis management, culling and stamping out for high impact on economy and zoonotic. And then for highly pathogenic avian influenza, at the moment we establish 1 kilometer radius from in that case, but it still depends on the epidemiology, pathogenesis mechanism of the disease, and also the farm management. If the farm management is so good, and then even though it's located within 1 kilometer radius from the index case, maybe we can spare this farm from being, the animal from being culled. So vaccination, not for HPAI. The HPAI still the control measures is to cull all the animal at risk. But for LPAI, H9N2 recently approved vaccination as part of control program. Movement control and farm quarantine, identification of outbreak area and surveillance, as explained just now, the zone. And then we will gazette the outbreak areas and the state for all the activities to be conducted properly. Disposal and burial of carcasses. We don't simply throw this animal into the general public waste. We have to properly dispose and decontaminate all this so that the virus won't spread into the environment and circulate and cause another infection. So as a part of recovery, we, for certain disease and certain situation, we do compensate. And then surveillance, then we advise the farmer to have this good veterinary husbandry practice, farm registration, animal registration, health cert, and then restocking. I think that's all. Thank you very much.
Thank you very much, Dr. Rozanah, for sharing your presentation. So for the last speaker for today's seminar will be Dr. Akma Ngah Hamid. Currently, Dr. Akma is Deputy Director General for Veterinary Health, Department of Veterinary Service, Malaysia. She's graduated from UPM in 1989, received a Master in Food Science from University Kebangsaan Malaysia in 2017. So Dr. Rozanah, Dr. Akma started working in Department of Veterinary Service since 1991 in veterinary public health. Then she joined VRI, Veterinary Research Institute in Ipoh, working under the bacterial vaccine unit. She also has been the state directors, state director in Selangor and Pahang since 2015 and 2019. Currently, the post that she's holding now as a Deputy Director of Veterinary Health Department of Service actually is since 2019. With that, Dr. Akma, the floor is yours. Thank you very much.
Okay, thank you, Professor Dr. Abdul Rahman Omar. Okay, the title of my presentation today is implementation of compartmentalization. In my presentation today, I would like to share some information related to the application and implementation of compartment to any farm or premises that is interested to apply compartmentalization. Also, I would like to share what's the benefit will be gained from the compartmentalization. And all my presentation, I put all my reference. So I hope that any farm or premise who are interested to apply or implement compartmentalization can easy to refer based on my slide. So we go for a definition of the compartmentalization. Compartmentalization is a procedure to establish subpopulation of distinct health status based on management and biosecurity factors, and the animal within the compartment should be contained in one or more establishment under a common biosecurity management system to preserve a distinct status with respect to a specific disease or diseases within the territory or country. And the OIE recommendation on compartmentalization in terrestrial code cannot be applied in all situations. The effective implementation of this concept depends on the many factors, including the epidemiology of the diseases of interest. For example, in poultry industry, normally related to Newcastle disease and highly pathogenic avian influenza. And also related with the environmental factors, the health status of animal in area adjacent to the compartments, for example, village chicken, and also surveillance and the relationship between the public and private sectors. So what is the purpose of the establishing compartmentalization or compartment in our country? The establishment of a compartment is a preventive measure serving both to guarantee the health status of an animal subpopulation and mainly to avoid interruption to trade in animals and animal products. As a country that exports chicken and eggs, and also as a major export of the country, it is important for us to create a compartment to ensure that the export of chicken and eggs continues with the presence of disease or exotic diseases such as highly pathogenic avian influenza. So it is preferable to establish a compartment at a time when the country or zone is free from the disease or diseases from which the compartment is being created. So we go for ORE definition. What is the differences between zone and compartment? Zone normally means a clearly defined parts of a territory or country containing an animal subpopulation with a distinct health status with respect to a specific disease for which required surveillance, control, and biosecurity measures have been applied for the purpose of international trade. And zoning applies to an animal subpopulation defined mainly on a geographical basis. And normally the basis is either natural, artificial, or legal boundaries. Whereas compartment means one or more establishment under a common biosecurity management system containing an animal subpopulation with a distinct health status with respect to a specific disease or specific diseases for which required surveillance, control, and biosecurity measures similar as in zone. And normally this compartment applies to an animal subpopulation defined mainly by management and husbandry practices related to biosecurity. So we can see the difference between zone and compartment. Compartment more on management and husbandry, whereas zone is more geographical basis. So here's some example for zoning. So normally if we have infection surrounding, so we can create zone free if we have either as I mentioned just now is either natural or legally boundaries. So for example, we have a buffer zone here, and maybe this separate from the infection is by major road, or maybe by railway station, or maybe by river. So, but in the free zone, we need to justify to the veterinary authority to ensure that this free area is comply with the zoning. And for compartment, it involves more establishment, as I mentioned before. And if we export live chicken, so maybe its slaughterhouse is not involved. But if we export poultry products, so all the establishment may be involved, and record must be transparent to the veterinary authority for inspection to confirm that this compartment is free for certain disease. For example, is in this zone, sometimes, for example, maybe Peninsula Malaysia or maybe some state we consider one zone, and maybe in one zone we have a few compartments. So and then as I mentioned just now, that the zone should be have the boundary from the infected area. So these are some of the example of the zone and also the compartment inside the zone. So concept of zoning and compartmentalization. Concept of zoning was developed in 1993, and the purpose is to limit the trade impacts to those parts of the country affected by the disease exist. However, compartmentalization was introduced following concern about the spread of H5N1 avian influenza in 2003. So this is the example of zoning in Asia for avian influenza for 1995-2004. So I just take about 2 countries that have a different zoning that they are practiced. For China, they have infected farm. So they are from within 3 kilometers from infected farm, they were stamping out all the chicken, no movement of going outside, and they practice, before that they practice the vaccination. That means from outside from 3 kilometers to 5 kilometers to 8 kilometers, and the 10 kilometers, that means after 8 kilometers they consider is a buffer zone. But for Japan, in the infected farm, they practice stamping out, and for 30 kilometer radius is they practice for movement control. So we can see it's a different between 2 countries. But for zoning in Malaysia context for avian influenza, so I refer this zoning is based on the protocol Veterinary Malaysia for highly pathogenic avian influenza. So the red color is the infected farm. So in the infected zone, we call within 1 kilometers, we will practice for stamping out. So we cull all the chicken in within 1 kilometers, and then we will conduct surveillance outside 1 kilometer up to 10 kilometer. So surveillance activity will conduct for 42 days, for 2 incubation period. But if no outbreak after 19 days in the infected and surveillance zone from the last cases reported, so we consider this area is a free zone. So there is a provision for the use of compartmentalization for the most of diseases that are important to the international trade. So since 2014, there is a list for the compartmentalization. So for pig, we can see that as African swine fever and classical swine fever, but in our context is avian influenza and Newcastle disease for poultry. And there is also compartmentalization for other disease like FMD, PSE, CBPP and PPR, and also equine influenza. But for IB and for other poultry diseases, is no compartmentalization yet. So how we want to apply for the compartmentalization? So based on Terrestrial Animal Health Code Chapter 4.5 in year 2019, so we go for the principle for defining a compartment. So the compartment should be clearly defined, indicating the location of each component. So the establishment and related functional unit must be stated. For example, feed mills, slaughterhouse, abattoir, rendering plants, and etc. and also interrelationship and contribution to an epidemiological separation between the animal in a compartment and subpopulation with a different health status. So for separation of compartment from the potential sources of infection, the management of a compartment should provide documented evidence to the veterinary authority, mainly on physical or spatial factor that affects the status of biosecurity in a compartment, infrastructure factors, biosecurity plan, and traceability system. So we can go one by one. What's the the requirement for the compartmentalization? So for physical and or spatial factors that affect the status of biosecurity and e-compartment and also infrastructure, it based on the biosecurity implemented by the farm itself. And this one we can, I can explain after this. Normally, for poultry farm, we need to have fencing, and also we need the concrete base to avoid from other pests. So for physical, compartment is related to management and biosecurity measures. Boundary provides separation from adjacent animal population with a different health status. It repeat again about the management and biosecurity measures. And related to the disease status in adjacent area and in area epidemiologically to the compartment. And also it involves location, disease status, biosecurity of the nearest epidemiological unit or other epidemiological premise. For example, flock or herd with a different health status in close proximity to the compartment, including wildlife and migratory routes. And also slaughterhouse or abattoir, rendering plant or feed mill. And also if market, fair, agriculture, shows, sporting event, zoo, if related or nearby the location of the compartment that they want to apply for the compartmentalization. And infrastructure factor, normally a structure aspect of the establishment within a compartment contribute to the effectiveness of its biosecurity, and consideration should be given to physical separation like fencing, facilities for people, entry, vehicle access, unloading and loading facilities, isolation facilities for introduced animal, facilities for introduction of material and equipment, infrastructure to store feed and veterinary products, disposal of carcass, manure and waste, water supply, air supply, feed supply or sources, and measure to prevent exposure to living mechanical or biological vector related to insect, rodent, and wild birds. So these are some of the example of good farm layout of broiler farm that maybe we can consider for the compartmentalization. So they have proper biosecurity. And also these are some of the closed house system that maybe can we consider that can comply for the compartmentalization. And this also is a part of the biosecurity plan. So normally the biosecurity plan is in the application should describe in detail about the potential pathways for introduction and spread of the agent into the compartment and survivability of the agent in the environment. So for example, animal movement, rodents, fauna, aerosol, arthropod, vehicle, people, biological product, and etc. And also they need to have the critical control point for each pathway, and also measures to mitigate exposure for each critical control point. And the premise of farm should have a SOP, including the implementation, maintenance, monitoring of the measures, application of corrective action, verification of the process, and also record keeping. And the farm or premise also should have a contingency plan addressing any potential future changes in the risk factor, and they have a procedure to report to the veterinary authority. And they also should have the program for educating and training workers to ensure workers are knowledgeable and informed on biosecurity principles and practices. And the surveillance program should be in place. So these are some of the example of the biosecurity facilities that they should have, and some of the room for disinfection. And when we talk about the traceability, so these are some of the example, the record of the traceability the farm or premise should keep. For example, is in the poultry farm, they should have a reserving of DOC, maybe the source of DOC from maybe one hatchery or more, or maybe from the same supplier or various supplier. So everything must recorded in the and must be in the proper documentation. And also the growing of the broilers. So the record of the body weight, vaccination and medication, and also during the harvesting of broilers. So the number of bird per crate, number of bird per house, veterinary health certificate and permit from DVS must be recorded properly. And the last one is transportation of harvesting broiler. If they send to the processing plant or export, so they must consider about the animal welfare and avoid heat stress during transportation and must be recorded properly. So that for the traceability system, the prerequisite assessment normally will done by the veterinary authority to assess the integrity of the compartment is the existence of a valid traceability system. An animal within a compartment either individually identified and registered, and for chicken, for example, broiler and DOC, the veterinary authority should provide sufficient assurance of traceability. Maybe this assurance can be shown by the using veterinary health certificate, and movement of animal into and out of the compartment should be recorded at the compartment level, and when needed, based on real assessment, should be certified by the veterinary authority. However, movement within the compartment need not be certified but should be recorded at the compartment level. So in terms of documentation, documents should be clearly evidence on the biosecurity, surveillance, traceability and management practices are effectively and consistently applied. And the evaluation of disease exclusion mainly related to the animal and flock movement information, flock production record, feed sources, lab tests, birth and death record, visitor logbook, medication and vaccination record, biosecurity plans and training documentation. So the farm or premise that have intention to apply for compartmentalization must have a good record for this parameter. And also historical status of compartment for the disease should be documented and demonstrate compliance with the requirement for freedom. And the compartment seeking recognition should be submitted to veterinary authority about baseline animal health report indicating the presence or absence of the disease. And report should be regularly updated to reflect the current animal health situation. And also vaccination record, what's the type of vaccine and frequency of administration must be properly recorded. And also all relevant information should be recorded in a transparent manner and be easily accessible when audited by the veterinary authority. And the surveillance of agent or diseases must be in place. So the surveillance system should be compliant with chapter 1.4. So you can refer to ORE manual, chapter 1.4 about animal health surveillance. Normally they will involve about internal surveillance and also external surveillance. And the surveillance for internal surveillance should involve animal subpopulation collection, and any analysis of disease or infection data can be certified by veterinary authority about the status of the compartment. But for external surveillance will help identify a significant change in a level of exposure for the identified pathway for disease introduction into the compartment. So the combination of active and passive surveillance is necessary to achieve the goal for the surveillance of diseases. So for diagnostic capability and procedure, so all laboratory tests and procedures should comply with the recommendation of the lab for the specific disease. Laboratory should have procedure and refer to the test method in place for rapid reporting of disease result to the veterinary authority. Until now, we have about 16 accredited veterinary laboratory, including DVS laboratory as well as private lab. So you can search from the official website of Department of Standard Malaysia, which lab that already accredited and can conduct for certain diseases that you are intention to do. For emerging response and notification, early detection, diagnosis, and notification of disease are critical to minimize the consequence of the outbreak. So we hope that any disease detected by the farm or premise must inform to the veterinary authority as soon as possible so that we can make or maybe we can conduct or surveillance and investigation and to confirm about that particular disease. In the event of suspicions of occurrence of the disease for which the compartment was defined, the free status of the compartment should be immediately suspended. This is the practice that we practice for the MyGap for the MyGap farm that not comply with our standard. If confirmed, the status of the compartment should be immediately revoked and importing country should be notified. So in the case that we have, for example, highly pathogenic avian influenza, so DVS will notify the importing country that we have the disease, and after that, when we can get freedom, so we will apply back to ORE and then we will inform to the important country to reinstate our exportation. And regarding the supervision and control of a compartment, normally this activity is actually is the role of the veterinary authority to supervise and also to grant about the compartmentalization. And normally the authority, organization, lab and infrastructure of the veterinary Veterinary authority should be clearly documented to provide confidence in the integrity of the compartment. Veterinary authority has the final authority in granting, suspending and revoke the status of the compartment. And also veterinary authority should continually supervise compliance with all the requirements to maintain the compartment status and ensure that all the information is readily accessible to the importing country. And any significant change should be notified to the importing country. So in the Malaysian context, the criteria for the compartment. So in the Malaysian context, it is encouraged for any farm or premises, especially to the exporting farm or premises or plants, to apply for a compartment, especially farm or premises that already have the following certification, such as MyGap, disease-free farm, GVHP, VHM, and etc. Also, I would like to inform that recognition of compartment is the result of a bilateral agreement between the veterinary authorities of countries involved and is intended to include specific conditions for continuation of trade even the event of changes in the healthy status in the country or zone. With that, thank you.
Thank you very much, Dr. Akma, for sharing very important information when it comes to how producer want to implement compartmentalization. The first question on probably we get views from Dr. Marcelo first. Is there any countries that vaccinating broiler to prevent H9N2 infection?
Yes, there are some countries, and I could name some of them. The first one is China. There are some countries in the Middle East, Saudi Arabia and others, and even Egypt. But I have to say that the results of the broiler vaccination are not as clear as compared to long-living birds like layers and broilers. The results are less obvious.
So, all right, thank you. Dr. Rozanah, Dr. Akma, you want to comment about, I believe that from the view, we are not allowing a vaccination against H9N2 in broiler. So, Dr. Rozanah, Dr. Akma, probably want to comment, please?
Okay, I comment first. Okay, actually, for information, we just revised our policy measures for using vaccine against LPAI, H9N2. That's why, as I mentioned earlier, after deliberate researching of the pro and cons, which is best control measures to control the situation of H9N2. That's why we go for the long life bird, that is the breeder and layer. So if we find some positive result from this so-called trial period using this vaccine for these two type of bird, maybe in the future, after we analyze the finding, maybe we can consider of vaccinating broiler. I don't know yet, but
Okay,
at the moment, that is the situation.
Okay, thank you. Dr. Alma, want to add anything? Do you have any additional input?
Okay, at this moment, we just allow on layer and a breeder, as Dr. Maznah mentioned just now. But in broiler, because we are, I mean, this is the first try. I mean, we can consider that is a first trial. Then, and we do not know about how about the protection of this vaccine. So maybe this we just I mean the farm that we allow only the very selected and high risk farm at this moment. So any farm or that interested to use, they need to apply to the DVS state and we will conduct a risk analysis before we allow their use. That's our stand.
Thank you. Thank you very much. I think it's a very important issue. I think I can see the justification now why we only allow the long life birds for vaccination. And I think, as I said, the practice vaccination against H9N2 varies from country to countries. Okay, great. Okay. Second question from Dr. Vincent. I think these are basically a general comment. I think probably, listening from the presentation from both speakers, I think I can see the importance why we need to vaccinate against H9N2. Basically, because when you have a disease that is spreading like a wildfire, and if you keep on doing stamping out, I think that would not be economical for a long run. I think I can see why we need to do this autogenous vaccination as one of the strategy to control H9N2. And of course, at the moment, Malaysia is not vaccinating H5N1, and of course, we are also not vaccinating H7N9. I think that's very clear. It's a very focused, targeted vaccination. At the moment, we only allow autogenous vaccine for very selected farms that are of high risk. Okay, that's quite clear. Okay. Okay, question for Dr. Marcelo. Okay, title of HI title of 6, is it good enough to give protection? Your comment, please.
But this was a surprise to me when I read this statement in one of the publications from Korea that they consider 6.2 as a protective titer. And I haven't seen this kind of correlation between titers and protection for H9N2 in any other publication. I would be very doubtful to state that, and I would say the higher, the better.
I think in terms of title, I think it's important we need to understand the higher is better. Of course, with protection, it can be clinical, or it can be minimizing virus shedding. I think that's something I think all of us quite, we know that the higher, the better you're going to get in terms of protection.
Yes, and we have the point of defining protection. It's only clinical protection. You want protection in the excretion of virus. So there are some definitions from scientific point of view that needs to be considered to answer this question.
Thank you. Well, question of compensation. Well, this is a very question that always raised by producer. Any of the two speaker from Department of Service, Dr. Rozanah, Dr. Akma, probably want to give some infos about compensation in case of HPAI outbreaks.
I answer first, and then later maybe Dr. Akma add. Okay, actually, under our Animal Act 1953, under Section 20, no compensation shall be payable in respect of any animal, bird or carcass infected with disease and destroyed by order of any veterinary authority. So there's no such allocation for the authority to pay compensation for any confirmed animal disease in certain farm, especially the commercial farm, you know. So last time we do compensate because it's a small holder, and then the number of chicken also very small. It's just like a token, not really a compensation, just a token to help the farmer to gain back their livelihood.
Anything to add, Dr. Akma?
No, I think Dr. Rozanah already explained.
All right, okay. Okay. Question on why H5N2 is the LPAI. I believe this is because of the monobasic cleavage site, probably, right? Okay.
Absolutely.
That's quite clear. MyGap certification benefit the farmer. How does it benefit? I think this is a general question, probably, right? Probably, I think it's quite clear in terms of how the MyGap certification can benefit the farmer. I think this has been well stated in the website. I think all the information is clear. Okay, a question by Mr. Dr. Azam, Mr. Azam. Okay, Azman, do we need to look into consideration about spillover for wild birds or waterfowls to commercial birds this can be a factor why we want to implement vaccination. I think I think from some of the comment I've raised from the speaker indicating only farms at high risk they want to go for vaccination. I believe I mean they have to apply for the to get vaccinated, right? Probably comment from
Yes.
yes, right? It's not basically I think they're going to be evaluation been done, and then once they approve, then they can start to do vaccination, right?
Yes.
Yes. And of course, cost-wise, of course, I think autogenous vaccine is a temporary measure, and probably in the long run, there are going to be probably different strategies we have probably need to put in place for us to make sure that if let's say vaccination against HPAI going to be a long-term strategy, right? Okay, this is why cannot export poultry meats to Sabah Sarawak.
Okay,
Please.
I add something. For your information, Sabah and Sarawak, they have different ministry from the peninsula. They have their own Ministry of Agriculture and they have their own rules and regulation. Okay, that's why I think they put a bit strict restriction to import products from Peninsular Malaysia.
All right. Okay. I think because of the different law, because the state government, it probably certain extra requirements and so forth. Okay. Right. One important good question here. Eggs from LPAI vaccinated farm, can we be marketed?
You mean market to where? Market.
Local or international? Okay. Probably you want to explain whether it's going to be a local market or is it going to be export market?
Okay, I think this is concerned more on market, export market. Okay, as being presented by Dr. Marcelo very much earlier, actually there's no risk if the chicken is being vaccinated against LPAI, H9N2. In fact, in the country that the disease, this H9N2 is so widespread or endemic, it is safer to use vaccine because it will reduce the virus load in the chicken, so the product is safe when we do export. I think maybe Dr. Marcelo also can explain on the technical aspect of using vaccine. By right, the country that want to import product from our country that been using vaccine, suppose there's no problem. And for your information also, certain country that is endemic with H5N1 that is highly pest also using vaccine in their breeder, but we still can import the broiler or the product because the risk is so minimal. Correct me if I'm wrong.
Yeah, I think you have a very, very valid point regarding we look into risk assessment. What is the likelihood for the virus to be transmitted through our DO chicks and also through eggs and so forth.
Even if I may add,
please, yes, please.
Even for human consumption, it's absolutely safe. Absolutely safe for human consumption coming from vaccinated or non-vaccinated pots. Absolutely safe. There is no risk. In terms of exports, then we enter in terms of international trade, and it becomes an agreement between countries. But for consumption, it's absolutely safe.
Okay. Right. Okay. Move on to the next question. All right. Okay. This is regarding can we vaccinate LPI in village chicken, because village chicken tend to have probably a long-lived birds. So comment please. Village chicken.
I try to answer this. Because as mentioned earlier, we just revised our policy in allowing using vaccination LPAI H9N2 only at the moment for our breeder and layers. So if the village chicken is the commercial village chicken, we will consider after we find some finding from these two type of bird, because
Right. Okay.
we don't know the status yet.
Understand. I think pretty much we have to evaluate from case to case whether is there a need for us to do vaccination in this so-called village birds. Okay. Right. Great. Okay. There's one question also asking about commercial test kit. Is there a test kit or kit that they can use to monitor or diagnose AI? Probably comment from Dr. Marcelo and also probably from Dr. Rozanah. Okay.
Usually for monitoring in terms of serology, the most common test is HI, and this is one. There is a commercial ELISA kit being registered in Malaysia. Probably it's going to be available soon. That is, there is one commercial company that is working on this to bring to Malaysia one of these kits. But serology only helps you to monitor the situation and to do the proper diagnosis, you have to go further in terms of disease investigation.
Anything to add, Dr. Rozanah, Dr. Akma?
Okay, okay. Mungkin Dr. Rozanah will answer, yeah.
Okay, to test, you mean the commercial test kit to detect for detection of antigen? I think it's available, you know, some sort like PCR, but this is more on mini PCR where you can do on the side. It can give you a quick detection of antigen for H9N2 after they confirm the influenza A, and then they can go to the subtype of this avian influenza. I think it's available commercially.
Okay. Dr. Akma?
Yeah,
Anything?
actually, the test kit is depends on the lab that you want to send. The sample. So you need to ask, and also the test kit or test method they use should be follow the OIE manual. Is more practical because we were seeing the same method. Yeah, we propose to use the method that suggested in the OIE. Yeah.
Yes, I think the method based on OIE, there are some recommended method based on serology and also the conventional method of doing virus isolation. Great. We have actually surpassed 1 o'clock by 3 minutes. I think it has been a very eye-opening, very good presentation from all the 3 speakers. I think I myself have learned a lot, especially when it comes to how to go about procedures and protocol about managing disease from Department of Veterinary Service point of view. Very important. When you look into AI disease of global importance with potentially zoonotic, I think if you want to control disease, I think all our industry players, producers need to work closely with the regulatory agency. I think this webinar is actually something very important. Thank you very much for all the speakers for sharing your experience, your views in this presentation. Once again, thank you very much to all the speakers, and thank you very much to all the delegates, participants for joining this afternoon webinar. With that, all the best. Stay healthy, stay safe. Good luck. Bye-bye for now. Bye-bye.
Okay, thank you, Prof, for moderate this session. And thank you to all panelists for the sharing. Okay, ladies and gentlemen, we have come to the end of our session. We Agro-Food Productivity Nexus team, in collaboration with Federation of Livestock Farmers Association of Malaysia, FLFAM, hope that it has been educational for everyone and the information gained from today's session would benefit to you all. Okay, just a friendly reminder, we have another series on 5th December 2020, which will be discussed on agro-food productive public health concern in poultry production. Okay, stay tuned. The webinar invitation will be emailed to all participants for your reference. It has been a great day and wonderful afternoon with all of you. Thank you again.